These are some examples of the typical spring ephemeroids in the subalpine meadows of the Qazbegi region. Yeah, this. And after this, after they ended their life cycle, they often disappear. They don't really die off, but survive with underground storage organs, like so-called perinatating organs, like bulbs and rhizomes and so on. Some of them even keep their leaves over summer, but usually they die back to their perinatating organ. So at this point I have a bit to correct my title, because in this work not only the spring ephemeroids in the true sense of the term were considered, but all the herbaceous spring blooming plants. Herbaceous because brushes and grasses were not counted. Okay. Now coming to some hypotheses. As I said, I compared two slopes, and the main questions were: are there differences in the ecological parameters between the slopes, and are there also differences between regarding the species richness and diversity between the slopes? And of course, the question is not only the difference, but are there correlations between these different factors? And at last, the last question is if there is a difference in the species richness between the spring data, which was collected by me, and summer data, which was collected already before. These are the so-called null hypotheses. So these are hypotheses that are to be falsificated. How I did it? To prove this, I did a field survey in the Qazbegi region of the Central Greater Caucasus, and the study sites were near the village Stepansminda. Here at the red point, you can see where the sites were, right near the street. So they were chosen because they are available, so nearby, easy to reach, and data for them from summer is also available. At this picture you can see the both slopes. On the left we have the northwest facing slope, and on the right the southwest facing slope. Here you can see that the slope angle, the mean altitude of the slopes, and the size of the observed area for the both slopes were more or less similar. Okay, on the both slopes, the survey was made in May of this year, in the middle of May, and two study series were made. And the first series, for each slope, 20 plots were observed, so 40 in total, and some days later additionally 10 plots were observed, so 10 plots per slope, so 20 in total. Each plot had the size of 1 square meter, so 1 to 1 meter, and the distribution of the plots you can see in this scheme. Here we have the northwest slope and the southwest slope. The plots lay on lines parallel to the slope. On the northwest it was 4 lines, on southwest, because it was more narrow, we did 5 lines. And on these lines the plots were chosen randomly. with the black marks, this is, as an example, marked the additionally 10 plots for each slope of the second series. And here you can see one example of a plot on the edge of the northwest slope. I first marked it with a rope and afterwards with wooden sticks to do the ecological measurements. Okay, but what did I measure? For each plot, at first I did a list with the species, and I counted the number of individuals and the cover after Brown Blanquet. And the ecological parameters were measured under standard conditions. So on sunny and cloudyless day, at midday, and in a time which was as short as possible. Per plot, these were measurements for surface and soil temperature, and also the soil moisture. In the same time as I measured them, for each slope were measured the illumination and the air and air temperature and air humidity. This was measured with no wind. And at last, from the second serial, so 10 plots per slope, were taken soil samples and afterwards measured the pH value. So, and for some analysis, for the to compare the slopes similarity, I calculated the Sørensen index, so a similarity index, and as diversity indices per slope, per plot, I'm sorry, the species number, and from this and the individuals per each species, the Shannon index and evenness could be calculated. So we have two different levels, let's say. One is of the plot, which was measured per plot, and one is which was measured per slope. For some statistics, the statistics software R was used, and for significant differences between the slopes, mostly ANOVA were used, and for correlations, linear models. When the data was not normal distributed, equivalent, the Wilcoxon test and Spearman-Rank correlations were used. Significances were observed when the p-value did not exceed 0.05. Okay, now coming already to the results, I'm starting with the environmental factors. First, the ones which were measured per slope. And here we can see the air humidity and air temperature with the scales on the left, and the illumination with the scale on the right. These were divided by the two sampling days, 14 and 17, for each parameter, and for both slopes, northwest in blue and southwest in red. And here we can already see that illumination does not show any significant differences, nor between the two dates, nor between the two slopes. So it's all the time more or less the same. Significant differences we could observe between the both days for the air humidity. So this was significantly higher on day 14 than on day 17, and the otherwise round for the air temperature. But within these days, no significant differences between the slopes could be observed. So between the days there were differences, but between the slopes there were no. only for the air humidity. On day 17, the air humidity was significantly higher on the northwest slope. Significances we can see when we have a look at the environmental factors which were measured plot-wise. Here we have only the data for day 17, and we have the pH value, the soil moisture, and the soil and surface temperature. In numbers it is like this. And here we have some significant differences between the slopes for the pH value. It is higher on the southwest slope, for the soil moisture, which is higher on the northwest slope, and the soil moisture, which is also higher on the southwest slope. Only the surface temperature did not show any significant differences. So what we want to remember from this, significant higher values for pH and soil temperature on the southwest slope and higher soil moisture at the northwest slope. So far for the environmental factors, having a look at the interesting part, or also interesting part, the vegetation data. And here we also can see quite high differences. I just remember this is measured per each plot, and here the species number per plot and the Shannon index show significant higher values for the northwest slope. Here as well in numbers. Just the evenness does not show any significant differences. Again, we remember the species diversity, let's say, is higher on northwest. Having a look at the bigger scale, not only per plot but per slope, we see a quite different picture, because here the species number is twice as high on the southwest slope than on northwest, so it's a diametrical difference to the number per plot. Yeah, we have 3 common species to both slopes, and this results in a similarity of 40% after Sørensen. So it's not very similar. This is the data for spring. As I said, I compared this data with data which was collected in summer. This was not my own data, but from Tefnaze et al. Et al. Is mostly sitting here, I think. And I got the raw data with the species list and the brown blanke cover, so I could do some analysis as well. And here it is. In summer, again, we have a difference. Here now the species number is very much higher on the northwest slope, and in total also the common species to both slope species are very much higher. This of course leads to a higher similarity. Yeah. Okay, at this point I just want to remember, in summer all the plants were considered which were growing. In spring only the plants which were blooming at that time. So that's of course a difference. Now we just compared the both slopes and saw difference between them. Now we want to correlate also some data, and as there is a very good correlation between species number and Shannon index, I will show here only correlations with the Shannon index. The correlations of the same factors with the species number does show similar correlations. Okay, the Shannon index was correlated with the soil moisture, and here we have a quite interesting picture. I just explain. The red one are the data for the southwest slope, and blue for the northwest slope. And for both slopes we have these lines. And you already see that it is quite different between the slopes. And when we have a look at the both slopes together, this black line occurs. Similar to this, the correlation with the soil temperature. This looks a bit different. And now to the statistics, because that's very interesting. Regarding both slopes, when we take both slopes together, we have a significant correlation between the Shannon index and the soil moisture, as well as with the soil temperature. So only having a look at this, we would have to say, okay, the Shannon index is increases with increasing soil moisture and decreases with increasing soil temperature. But dividing this both data sets of the northwest and the southwest slope, we see that the soil moisture already does not have a significant correlation with the Shannon index, nor for the northwest nor for the southwest slope. And also for the soil temperature, here is only a correlation between for the southwest slope between these two factors. With this, I already end the results and go on with the discussion. And I will stay on this slide because I think it's quite interesting. As I said, for example, for the soil moisture, we have to divide this both data sets because we get a significant correlation when we look at them together, but this significance disappears when we look at them in parts. It can be explained by that there is a significant difference between the soil moisture and the Shannon index between the both slopes. And of course, if you have a significant difference and look at all, then the correlation will be significant as well. But looking only at the subsets, let's say, this significance disappears. Okay, that's so far. Now for some discussions to plot and slope. I just remember the species richness was higher on northwest regarding the plots, but higher on southwest regarding the slopes. How can this be explained? I think this already shows that the southwest slope has to be much more heterogeneous, because a small example, when we have, for example, like here on the left, 3 species which all are distributed homogeneous, then just drawing some plots inside, we almost all time have at least 2 species, sometimes even more. Doing the same at the heterogenic distribution, where we in total have more species, but they are distributed heterogenic. Then we can draw different plots and have maybe 2 species, but mostly even only 1. And this is what happened here. On the southwest, some of the plants occurred only on 2 or 3 places, and on the northwest slope, most of the plants were distributed very homogeneous. An explanation for this can be the density of the Festuca tussocs, because on the southwest slope the tussocks are quite more dense than on northwest, and having denser tussocks means that between the tussocks there's more space, and this supports the heterogeneity of this slope. Going on to compare the both slopes now. To remember, in total we had more species on southwest. And already Abdalaze et al. Discovered that for early spring ephemeroids in the Caucasus, there's no competition for soil moisture observed. This can be supported by the non-significant correlations we had. But which else factors can lead to this? Very important factor is always the soil temperature, and here we have a higher temperature on the southwest slope. And also in the literature you can find that these processes, which are temperature driven, are very important for the species richness. Winkler et al. Had observation or compared different slopes of temperate European mountain summits, and for example looked at the temperature, and here you can see these are the different slopes and the temperature sums, and here you can see that at east and south facing slope the temperature is significantly higher than on west and north facing, and we have also on these slopes higher species richness. They correlated this data and had a significant correlation between it. So it means you can say the warmer the richer. The warmer a site is, the richer it is in species richness. This is not always the fact, can be seen when we compare the spring and the summer data. To remember, in spring we had more species on the southwest slope, in summer more species on the northwest slope, which is to be considered as not as colder than the southwest. Here again. So there have to be different factors which play a role, not only the temperature. And what can be an explanation is the lower festuca cover on the northwest slope, because here there is more space and more species can occur, and the competition, the interspecific competition might be not as high as on the southwest slope. Another fact which should be considered, of course, is that in summer, as I already said, all the plants were considered. So here we also have more plants which have a wider adaptation of, or a wider range of the different factors where they can live. The similarity is higher in summer, and this is the same explanation, that here more species on both slopes occurred, which were, for example, in the spring just not counted. For example, only to take festuca and carex, which occurred on both slopes, we already would have had more common species. And as the Sørensen index lies much weight on the species which are common to both slopes, this similarity would already rise. Okay, with this I already come to the conclusions. Coming back to the hypothesis I stated in the beginning. The first was, in spring the ecological parameters do not differ between the slopes. Here we can say it is partly correct, partly not, because some of them do differ, mostly the soil parameters like pH, moisture and temperature, but others do. So here it is a partly. The second hypothesis was in spring the species richness and diversity do not differ between the slopes, and this we can deny because in spring the species richness per slope was much higher on southwest slope, so this is disproved. The third one, correlations between ecoparameters and species diversity, can also be disproved. We found correlations. Some of them were significant, so this is also disproved. And at last, of course, the comparing spring and summer data, we also see a big difference, even a diametrical difference. In summer, the species richness is higher on the northwest slope. And with this, I come to some outlook. From this data, we can see that the plant communities are not static. They are dynamic, and this is maybe the lowest level of changes in communities we can observe. The changes over one vegetation period. This is called the phenological change. And here we come to some important points, because as it is, I think, already common knowledge, high mountain ecosystems are very vulnerable to climate change, and as well the climate change leads to phenological shifts. So this can be seen as an important factor which can be observed and should be observed in further times, so we can have a look how the communities change over time, over one vegetation period and in between the years. This, of course, needs not like this work only one observation, but a continuous look. So it should be done several measurements or observations per year, and also I think it is important that for the ecological parameters that they are measured not once a day but several times, because in this case you can see very many other differences. For example, the amplitude of temperatures between night and day, if there is frost in the morning or not, and also the clouds and illumination. Here are some of the references I used, and at the last point I have to thank many people. First, of course, very many thanks to the Ilia University that I could come here and write my bachelor thesis. A lot of thanks go to my supervisor, Ota Abdaladze. Thank you for everything you did for me. And for the people of the working group, Arsen and Zezwa, who helped me collecting my data, and Taco and Tamar, who helped me, Taco and Ketavan, I'm sorry, who helped me with pH measurements and so on. And at last, I want to thank my German colleagues who came here and helped me a lot from abroad. And last but not least, of course, thank you for coming here and listening to me, and I hope for asking me now many questions.
Thank you for this analytical talks, and I believe there will be questions and comments from the society, present society. Zura?
Thank you very much for presentation. The first question is like this. As I understood, if I understood correctly, during the spring you were measuring only flowering.
Yes.
Flowers, so flowering species of the flowering plants.
Flowering species.
Which were flowering at that very moment, right?
Yeah, the species which were flowering at the moment, but not only in the plot. So it was not important for the single individual if it was flowering or not. If one of the individuals of the species was flowering on one of the slopes, I counted every individual of the species.
Yeah, so, and in the other data set which you presented for the summer, they counted all plants?
They counted all, yes.
Kind of flowering or non-flowering?
Yeah, all which occurred in the thing.
Yeah, so in that case, can we deduce after that actually maybe on the southeastern slopes, there are more plants, more species, because it was just warmer there, and in the spring that's where they start to flower earlier. On the northern slopes, obviously, right?
Yes.
And how we can compare that data set to the data set which was actually presented?
Of course, you have to keep in mind that the spring data is only about the blooming data. But here it was to have a look at this ecological group, let's say, and to look if the richness within this group is the same or different to the overall richness on in summer. Yes.
So you were saying that here that you can say that perennial diversity of the perennial plants on the southern slopes were actually higher.
Yeah.
But in reality, the plants were higher on the northern slopes.
In spring, we did not count the total number of. Yeah.
I mean, they wouldn't. If they're gonna appear, right? They were there.
Yeah.
Right? We already know that because we measured all the plants without perennials or whatever, just all the plants. We know that actually on the northwestern slopes, diversity is higher, right? But the perennial diversity is higher on the eastern slopes, right? That's what you say.
Yeah, on the southern, yes. Yeah.
And in that case, how then afterwards then kind of dealing with the hypothesis, how in reality that's kind of play off? Is it gonna still stay if we consider that we're not measuring the diversity of the plants, but we're measuring the diversity of the particular plants? Are those hypotheses still gonna give the same result?
Maybe I should have written it in the hypothesis that it's always about the spring blooming plants and the total plants in summer, and not at the plants in total.
Diversity in your sentence, you have the species diversity, not like perennial, as I understand.
Yes. That's.
So is it correct to say species diversity rather than actually in that case particular species?
Yes. I should have mentioned that here. Yeah, you're right. So it should be in spring the species richness of the blooming plants is higher. Yeah.
Sure.
Yeah. So.
Thank you. Any more questions or comments? Think so?
Sophie, thanks a lot for the well-structured and clear presentation of your research. My question is, how do you explain the non-significant difference in illumination between the slopes?
Where is it?
Somewhere at the top.
No. Okay. I think an explanation can be that these both slopes are very close to each other, and it was measured always on midday, so when the sun is quite high already. So I think there is no big difference between the both slopes on midday. that is one of the reasons why these measurements should be not done only one day, not only once a day, but several times, because I think in the morning it will look different.
Thank you.
Any more?
Not only because of that. You see this Western orientation. You have on the both slopes Western orientation anyway.
Yeah.
And it makes the difference.
Yeah, so it's not like 180 degrees. Yeah.
If you take clear north or clear south or clear east, then you will have much more differences.
Yeah.
There is one thing, generally very nice work, I think, for such small period of work. You findings are also interesting. I did not expect such big difference between this early spring species, between these not so contrasting slopes. And this is nice finding, actually.
Yeah.
Very nice finding. And yes, actually, I also think that this is mostly general. It is because of temperature.
Because of what?
Because of generally this southern slope are warmer in this period. Yeah? I mean, in the early spring, which is very important for this period to be warm. Then you have more species during the summer period in the northwestern slope. Then because in summer period, then it can be overworked, southern slopes.
Yeah.
It's not only the advantage, maybe, which is clear advantage in springtime. This can be not advantage in the summertime.
Yeah.
And it is more wild, more amazing, these northwestern slopes, they have more species diversity. I think very nice. Very nice.
Thank you. More, please.
Thanks for that presentation. As a zoologist, I always also look for not only abiotic factors, but also, of course, on biological factors. So, of course, not in spring, but is there any difference in grazing in the summertime in these different slopes, or are they grazed quite the same way?
No, I think the northwest slope, as I had it in some data, is used as a hay meadow, so it's cut, and the southwest slope is rarely grazed by cattle. I think, yeah. So there is a difference also in the use.
Yeah. Well, this one.
Sophie, first of all, I want to thank you for very interesting presentation, and I should also say that I have to congratulations to you for very interesting research. I remember that you first were planning to investigate these two slopes at the first time, but I liked that you also involved the differences of summer vegetation. I mean, you first were planning to investigate the spring ephemerals vegetation differences and compare them, but it was a really good idea to involve the summer plants as well, summer, so to say, populations of the plants there in your research. But I have just one question, which might be not only for you, it's not directed to you, just for discussion. So you measured these parameters on one slope in quite large area of Qazbegi. How do you think, is your data somehow can be generalized for this region or this elevation? How do you think?
So my guessings would be, of course, generalizing is always difficult. If you want really to generalize, then you need to have different plots. But I think you can see the changings in over the years, because, as Ota already said, these slopes are already observed several decades. It's the same slope, and so you can say the changings can be observed, can be measured. But of course, for generalizing, I would say that you have maybe to see different places. I don't know if somebody has other ideas.
Maybe the last question. Are you interested in continuation of such research? Mountain plant ecology.
I have to say I love plants and I love mountains, so of course this was one of the perfect matches. Let's say I would not say not, if I have the possibility. At first I planned to the next year to travel with my husband and then just start or go on with the master degree. I think it will be about biodiversity and ecology. So I will keep this
experience.
Yeah, I will keep this open, and if there is a possibility in some time and I can come back, yes.
And I will allow myself also to ask a couple of questions. So the first is, you mentioned that these differences between the northern and southern slopes in the spring and summer can be explained not just by temperatural differences. In this case, well, I am just trying to get the simpler explanation. So that's, I suspect that the temperature in spring in the southern slopes is higher, and in summer in the northern slope it is lower. So that means that perhaps there is a certain tolerance limits which satisfy higher number of plants. Whether the temperature limits or sum of effective temperature in the spring on the southern slopes is comparable with that in the summer on the northern slopes. So whether this could be just be explained by, I don't know, just a higher closeness to a multiple optima for different species.
That's a very interesting question. I think I did not have data for the temperature for the summer, but this is a good question to have a look at. And of course, that it's not only explained by the temperature, it's called so-so because many of the differences which can be observed are because of temperature-driven processes.
Yeah.
So also,
it's multiple influence. And in this respect, just, I don't know, maybe it's a question or comment. If you go back to the figure, where are the correlations? Correlation coefficients with this 10.
This one?
This one, yes, exactly. And you see, you have a certain correlation. Well, it is a soil moisture data is a little bit, it's very heteroscedastic, so it's a broader variation of Shannon index in the northern slope than on the southern slope, as one can conclude from this graph. And if you take an overall correlation coefficient, it looks to be positive actually. So this could be like a pseudo result. Negative for, and there is a little bit better correlation of Shannon index with soil temperature. Actually, these factors like soil moisture, soil temperature, of course, are not independent of each other. And whether you used a, I don't know, like a approach using either partial correlations or a multiple regression for inferring joint.
Yes, I used multiple correlations also. When
then I missed probably.
No, it's appendix, so I did not show it before. I did also linear models for this correlations I showed. But when I took soil moisture and temperature as independent factors, then the soil moisture was not significant, but only the temperature was significant for the Shannon index, for example. But of course, if you take factors which are correlated with each other, then one of them usually falls off. And yeah, here I think it's also a quite interesting correlation, because looking at the total data set, we have a quadratic,
square dependence.
What is, I think, not very logical for correlation between moisture and temperature, but looking at the slopes individually,
I think it's logical actually,
yes?
Because you have a flat, you have on the low temperatures, you have just very little evaporation, and then quickly increases.
Yeah. Okay. Yeah.
It looks like, I don't know.
Yeah, but I think it's interesting because dividing this in the northwest and the southwest slopes, we see like different correlations. Could be explained maybe that is still spring and maybe some frost is still in the earth on the northwest slope. And here, of course, when the temperature is higher, this melts and it's in higher moisture. And on the southwest slope, it could be stated that here this moisture, is already melted, and then the, let's say, usual correlation with increasing temperature, decreasing moisture occurs.
Okay, thank you. It was really interesting. Thank you very much, and wish you much success.
ძალიან საინტერესო მოხსენება, სხვადასხვა მხრივ, მეთოდური, ინსტრუმენტალური, geografიული, biogеографიული und so weiter. Das ist sehr interessant in verschiedenen Sinnen, zum Beispiel methodische, neue Methode, neue Instrumente und andere. Vielen Dank für diese. Und auch აგრეთვე ძალიან საინტერესოა ისტორიული თვალსაზრისით. ეს არის ის ნაკვეთი, სადაც 30 წლის წინ, უფრო 40 წლის წინ მუშაობდნენ ქართველი ბოტანიკოსები, გერმანელი, ავსტრიელი ბotanikusები. Das ist sehr interessant, auch in verschiedenen historischen Sinne. In dieser Probefläche arbeiten viele Botaniker. Inzwischen auch deutsche Botaniker, zum Beispiel vom gleichen Stadt in Bremen, Professor Gräb, Karl-Heinz Gräb. Und alle diese Sinne das ist sehr interessant. Und interessant auch methodische, საინტერესოა აი ცენარების შერჩევის ადრეგაზაფხულის ფლორის თვალსაზრისით. Im Frühlingspflanzen, das ist besondere Frage, besondere Frage. Dort ist verschiedene, mit dem Knollen, mit dem Würzen, mit dem und anderen სხვადასხვა ეფემეროიდები, სხვადასხვა სასიცოცხლო ფორმები წარმოდგენილი. მაგრამ ეს ცელოზი, ეს ეკოსისტემა არ არის კლიმაქსური, არ არის ძირეული, არ არის ძირეული, თუნდაც იმიტომ, რომ ის მდებარეობს არათავის არეალში. ფესტუკა ვარია ეს არის ალპური თანასაზოგადოება, ალპური ფორმაცია და გვხვდება ალპებში, ალპურ სარტყელში უბრალოდ სამხრეთ ფერდობებზე, ძლიერ დახრილ სამხრეთ ფერდობებზე. Das ist auch sehr interessant, aber das ist keine stabile Zellose, keine stabile Ökosysteme, keine Homöostase, keine Klimaxgesellschaft. Weil, wenn wir mähen, dann am nächsten Jahr dort war Kalamagrossis Arundinace. Keine mehr Festuca, besonders am Nordhang. Aber ist imito dort, ist das Itibeba, Kodeslegi, Nivedita Verabizavit, Köniabret. Aber die Klimaxuli. Ruitibeba, Iquitardeba, Kalamagrossis Arundinace. Tipuri, Subalpuri, Alkanaritris, მოსაზღვრე ცელის ეკოსისტემაში. აი ეგ არის. ასეთი ტიპიური ფესტუკა ვარია, ტიპიშე ფესტუკა ვარია ის ალპინე შტუფე. Klimaxgesellschaft. Im alpine Stufe am Südhängen. Sehr besondere Landschaften mit aber auch, ich muss sagen, das ist sehr interessant. Praktisch ist sehr leicht, sehr nahe mit anderen. Mehr Klimaxgesellschaft ist das ist Südhang, wenn sie gehabt dort. Südhang und Pro. Klimaxulia wird gewohnt, სამხრეთი ნაკვეთი. ისიც გარკვეულ მონაკვეთზე მხოლოდ. ეს არის ესეთი ამომრჩული რელიეფი, მშრალი და ასე შემდეგ. აი ეს ვიდოდა მეთქოდათ, vielen Dank für Ihre Teilnahme in unsere Untersuchungen, unsere Forschungen und vielen Dank.
Ich danke Ihnen.
Vielen Dank, Herr Kollege, für diese Idee der deutschen Botaniker arbeitet.
Vielen Dank, Lob an die
მაშინ ბატონო, დიდი მადლობა გასწრებისთვის, დიდი მადლობა ჩვენს მომხსენებელს მისი მოხსენებისთვის. Thank you very much for attending this talk and thank you very much for providing us with interesting information and some food for thinking.
Thank you for this opportunity.
Thank you.